start off with a quick review. And you might have done this right, but I had a number of problems with this particular assignment. So I'm going to go over and sort of sketch out the assignment, then it'll be up to you to sort of finish it off. All right, this is lab 6, I believe, where it says a publisher offers 3 kinds of subscriptions for its magazines: basic, student, and premium. Right off the bat, that tells you that you're going to have 3 classes, pretty much. All right. Now, every semester, I get some students that try to say, well, can I just have one subscription class, but with a flag that says the type of subscription? You could. That makes it harder to maintain now, because what if a 4th subscription type was added? That's easy then. You just create a 4th class, override the basic class, and there you go. All right, with whatever the differences are for some special, maybe an international subscription or something like that. You would just override, you'd create a new object, override it. Whereas if you were to do that with a flag, you'd have to go through everywhere and find where that flag is used and update it to accommodate the new subscription type. So a solution with a flag is makes for more complicated code inside the class, and is harder to extend. So we're going to have 3 classes, and we could have 4 classes. We'll talk about that in a second. Let's read through the rest of these, and we'll come back and make some decisions here. Basic and student subscriptions both expire 1 year from the date the subscription started. Premium subscriptions expire 3 years from the date subscription started. Basic subscriptions cost $20. Student subscriptions are 75% of the basic subscription. Premium subscriptions cost 250% to the basic subscription. For every subscription, we need these. And student subscriptions need also to have the student name and the ID number. We need to be able to calculate the cost renewal, the expiration date, create the relevant classes, thoroughly test. Keyword in that sentence is thoroughly. All right. Be sure you test every possibility. All right. If you just ran this with the basic subscription, that doesn't cut it, because you don't know for sure if the other classes are right. So this would require at least 1 of each subscription, and I would probably do a couple of each subscriptions just to make sure that all the calculations work the way that I expected to. All right, so let's talk about our classes. We could do one of 2 things. We could make an abstract class called subscription, where we put in the methods that each class needs to implement. And we could put these other attributes. Or we could make our basic subscription the base class. That's what I'm going to do, because the basic subscription really is a subscription. There's really no benefit in this case, I think, to creating an abstract class. So I'm going to make the basic class the basic subscription class is going to be my base class. I'm not going to create that abstract class. So I'm going to have a basic subscription class. Do pay attention to Java standards. For a class name, it should be capitalized, and each word in the class name capitalized. For methods and for attributes, it should be camel case. That is, the first letter is lowercase, every subsequent word is uppercase. I'm going to then create 2 other classes that derive or are inherited from the basic subscription. So I'm going to create student subscription. extends basic subscription. And also premium subscription also extends basic subscription. Now, does that match the rule for inheritance? Yes, because a student subscription is a subscription. A premium subscription is a subscription. So they match, they follow the rule, and they do share attributes, and they share methods as well. All right. And methods are probably more important than attributes as far as sharing, because it's a code that you want to reuse. All right. So we have these three classes to start with. This is our starting point. Notice we do not have anything that's like a flag that says this type of subscription is this kind. We only have it based on the class that we are creating. If you really need to know the type of subscription something is, like if you have an array list of subscriptions that you're looping through, then you could ask if it's an instance of basic subscription or student subscription or premium subscription. All right. So now, what are we going to put in each? Well, we said that these attributes belong to every subscription. So those attributes are going to be in attributes of the basic subscription. And we're going to have the get and set methods for all attributes. What do you think our constructor should be for the basic subscription class? How many arguments should it take? Yeah, I would create a constructor that took all the attributes as arguments. It would take an input date. All right. In other words, if you're GUI or if you're test class, it would create a date object and then initialize that date object. Now, I could see the argument, well, no. Every subscription is going to have all of these, right? So it probably would need all of them to start. So my constructor, I'm going to put that needs all 6 attributes. Now you can change it, right? You could change if they were on the phone, they said they renewed their subscription, you could put that in and it would bump it up. So there still needs to be a set for date subscription started. All right. Okay, all 6 attributes and use sets to set them. All right. Student subscriptions need to have the student school's name and student ID number. Where are we going to put that? Yeah, obviously in the student subscription. So we're going to define 2 attributes for the student subscription. Student ID and school name. Do we need to identify the other attributes? No. Do we need to define gets and sets for those attributes? No. That's all done in the basic subscription class. But not every prescription has a student ID or a school name. Now you might ask, and this again gets into problem with the type. You might ask, well, if I put a flag in there that said that what kind of subscription it is, I could have these fields in there in this table, and you just wouldn't set them if they were not a student. Well, that leads to problems because you could potentially then have a basic subscription that has a student ID and a student name. And that's not a valid situation. Because if you put them in this class, they would have to be optional. And as optional, you'd be able to skip them. And we've already identified we don't want to be able to skip these attributes. So we're going to put in there these things. And we're going to put in there sets and gets for those two attributes. All right. Now, we'll come back to the methods later on. I want to handle all the attributes. Our constructor is going to require all 8 attributes. And it will call the superclasses constructor and set the other 2 attributes. All right. Now, premium subscription does not have any different attributes than a regular subscription. So we need to be able to calculate cost of renewal and expiration date. All right. And it's based on these rules: the expiration date, the cost of renewal. So we're going to put in this class those 2 methods. Calculate cost of renewal. Calculate expiration date. All right, so we're going to put the formula in for a basic subscription at $20 for a basic subscription 1 year from the date the subscription started. I'm not going to write the code. You need to have some of the fun here, so you get to write the code to finish this off. Now, are we going to override those functions? Yes, we are. In student subscription, are we going to override the cost of renewal? Yes. So we're going to put in this class a cost of renewal. And what is the cost of renewal? I'm going to call super and multiply by 0.75. Notice how I don't simply say that it's $15. I say it's 75% of the basic subscription. That sort of implies that if I raise the subscription to $24, that's going to also affect the student price. It's going to up that as well. So that's why I'm calling the super, to get the base. All right, and multiply by 0.75. Calculate cost of renewal for the base class is going to be 20, and expiration date is going to be 1 year. Do we need to call that for, do we need to call the calculate expiration date? No, because basic and student subscriptions both expire 1 year from the date. So if we leave that method not in the student subscription, it will call the method on the superclass if I ask for the amount of the, or how long until the subscription expires. All right. Premium subscription. Does this have any new attributes? Oh, yeah. Does this have all new attributes? No. So my constructor is going to be simple. It's going to be for all the 6 attributes, and it's simply going to call super. Does it override calculate tuition cost? Absolutely. Does it override cost of renewal or expiration date? Absolutely. So we put these methods in here. And this is going to be, I think we said 2.5 times basic, 2.5 times super. And this is going to be 3 years. All right. So when we're done, we're going to have a basic subscription class that has all these attributes, get and set methods for all of them, a constructor that takes the 6 attributes, a calculate or get cost of renewal. Usually if something's calculated, I precede the function name with calculate. You could put get there because it's doing the same thing, it's getting it. Or calculate expiration date as 1 year from the date the subscription started. So all those things are in the basic subscription class. We're going to extend that for the student subscription. We're going to add these 2 attributes. We're going to add sets and gets for them. And we're going to have a constructor that gets all 8 attributes that's going to call the superclass constructor for the 6 of them and set the other 2 attributes. And the cost of renewal is going to call the super and multiply by 0.75. The premium, we'll have a constructor that gets all 6 attributes, 2.5 times super, and 3 years is the expiration date. Now, if you completed it and you completed it correctly, you're probably saying, wow, you gave away the answer, which I guess I kind of did. All right. But if you're having trouble with this and you're struggling with this, make sure you understand what I'm talking about here. Take a look at what you turned in. If you didn't get full credit, take a look what you turned in and compare it to this and correct it. And this shows one important fact. What I did here is I did not write the program. I designed the program. And that's a critical skill to have, even if you're the person that's going to write the program, right? Depending on the organization, maybe you're both the analyst that designs the program and the programmer that's going to code it. But in some organizations, they have senior developers do the design and junior developers do the actual coding. So either way, there's a benefit to doing the design first, because once you complete the design, hey, I gave you the blueprint of everything you need to do. As long as you know the Java language, writing this code should be a piece of cake for you. Because most of the work in programs, believe it or not, doesn't come in the coding. It comes in the design of the classes, where you're going to put methods, where you're going to put attributes, what you're going to need to override, and so on. Now, and I'm not talking to the people in this room, but everyone in the class, you might be struggling with Java syntax. That's okay. So when I say that coding is the easy part, I'm talking about it will become at some point in time the easy part. Might not be today. So it might be still a struggle for you to figure out how to code it. But at some point, the coding will be the easiest part, and the design is where you're going to put the work in. All right? So take a minute to do what I did for future assignments. Sketch out the classes. If you can think that through, and if you want, email it to me, and I'll take a look at it and say, yeah, you're on the right track, or no, you need to rethink these things. I probably should at some point require designs to be turned in. All right. The other thing is test thoroughly, which you need to test to make sure that all the scenarios work. One of those might include a leap year scenario, all right, to get the right expiration date. What you could do, and remember, how's this going to be used? You probably will have an array list of basic subscriptions. You'll add all kinds of objects to your array list, and then you'll loop through them all and ask each prescription, when do you expire and what's your cost? Repeat that. That good question. The question asked was, do we have to worry about the leap year calculation? And my answer is yes. Now, it's gonna sound like I'm talking both sides of the issue here. Yes, we have to worry about it, but yes, it's probably handled by the date class. We just want to verify that. Okay, so we will test that to make sure it works the way that we expected. So, you're responsible for testing, how everything works together. And that might include a class that someone else wrote. Maybe they had different assumptions, or especially if it's a class that one of your colleagues wrote and not one part of the Java framework, they could have a bug in their class. All right. So by testing your stuff and making sure your stuff works is a good way to sort of double check their stuff as well. Other questions? All right, let's get on to interfaces. All right. And I'm going to come up with a brand new scenario that we're going to talk about. Because it's important to tie these concepts to an actual need. All right. It's not enough for us to just talk about these things abstractly. And that's one of the weaknesses I found in a lot of programming textbooks, is they talk about, like, let's say we have an array of doubles and we want to figure out the sine and cosine of each one of the things. It's like, yeah, that's cool to know. It's a good way to illustrate it, but that's not really how you're going to use it probably. So let's talk about this scenario. We're a company that does something. All right. Let's say we're the college. All right. Now, we're the college. Or it could be any kind of business. A business needs to communicate to a lot of different people, right? A lot of different people and organizations. All right. So at a typical college, you might want to be able to communicate with students. You might be able to communicate. You might want to be able to communicate with faculty. You might want to communicate with area businesses. Businesses that we know they're in the area that maybe we want to post that we have a job fair. All right. We might want to talk to our suppliers. We might want to communicate with textbook publishers. All right. Actually, I'm going to make this a list. And there might be some more that we're thinking of. Now, without really stretching it, it's hard to put these things in a traditional inheritance format, right? We have student classes. Do we have our faculty students? No. Are faculty, you know, are students faculty? No. With students, there could be graduate and undergraduate, or PSEO. Not, they don't call it PSEO anymore, but whatever high school students are that take college classes. With faculty, there could be adjunct and permanent, and there could be other kinds of employees. So we could create employees and have faculty inherit from that, and have full-time faculty, part-time faculty. So we could make an inheritance structure. Area businesses, though, are neither faculty nor students, and they're not even a person. So if you try to think, we could make these people in our structure, that kind of falls apart. All right. Suppliers are also businesses, and so are publishers. The point is that these are going to be all through our application and all through the inheritance structure. So we can't put a function like send email to all of these different groups of people using the inheritance structure. All right. So we could create what's called an interface. An interface is like an abstract class. You do not make instances of the interface. You use other classes to implement that database. And what does it mean when you implement it? It means that the members or it means that the class that you implement the interface in has to have a certain set of methods. I've heard it called a contract or a promise to have all methods that are in the interface. So in this case, I might create an interface that says emailable. Means I can send an email to this class. And these things are scattered all through the inheritance chart. All right, but they have one thing in common. All right, they are able to send emails to. That would mean each of these classes would have to have in it a send email method. Now, they could implement that method a bunch of different ways, right? The rules for how to comprise a student email is different from the rules to comprise a faculty member's email. And area businesses don't follow a particular pattern. It's just whatever their email address is. Now, why do we do this? Because we want to treat email as a polymorphic function. What does that mean? It means, let's say we have a mass email that we want to send to every member of the campus community, regardless of which category they fit in. We could create an array list of emailable classes. And then these classes would all be created, and we want to loop through that and call the send email method. All right. When we do that, we have to make sure each one of them has that send email method. And that's why we create an interface, because that will guarantee that each of the classes that implements it has whatever functions that are required by the interface. Now, could have more functions, certainly, right? Faculty, you don't only send email to faculty. Faculty does a whole bunch of things. You don't only send email to students, and so on. All of these things have their own way of operating, right? And they have their own methods. But if we make an interface and implement them, we can guarantee all the members of that will have an email address. Now, here's the nice thing about interfaces, is there's not a restriction of how many interfaces you can implement. All right. I could have a mailable interface. In other words, people that we can send mail to, like regular physical mail. We could have phoneable. All right. And maybe the mailable has get address. Maybe Phoneable has a get phone number. And calling a student is different than calling faculty, right? If you call a student, you're going to have their outside phone number. If you call faculty, you might have their internal extension. So the details of the function are going to be different from class to class. But we can guarantee if it's phoneable, it has a get phone number method. If it's mailable, it has a get address method. If it's emailable, it has a email address. Or it has a get email function. Or send email in this case. So let me pull up the example that I have of interfaces. The classes that implement the interface. You don't extend an interface, you implement it. Implementing an interface means you're using this interface. So I think I have an example here. I hope I do. Yes, I don't. Well, let's create one. Oh, no, this isn't it. All right. We'll try to create these as quickly as I can. I always like to have prepared examples. I thought I did have one, but let me call up Visual Studio Code. First thing I'm going to do is I'm going to create my interface. So I'm going to say public interface emailable. By the way, I don't even think you need to declare it public. Interfaces by definition are public. It would make no sense to create an interface that other classes couldn't use. All right. Then I'm going to have a method in here that looks like a method, but it only contains the signature. Public int, let's say, send email. I could even do something like, if I wanted to for a student, send them Canvas email instead of like email. All right. So all I do is declare that, and I declare any arguments that the function has to have. Now everything has to match that signature. And I'm going to compile these one step at a time, because I just know that when I'm coding up here, talking at the same time, it's easy for me to get distracted and not do something right. So I'm going to make a folder called interfaces. Enter Dave's. I'm going to pull this in here, and I really messed up. I called it .text. So let me rename it to not enumerable. Emailable .java. Okay, now let's go in the command line and compile this. Make sure I got everything right. I often tell students to do a little step at a time, and I think sometimes students think I'm exaggerating, but that's literally how I code. I will do a tiny bit at a time and compile each time I do it. That way, if I make a problem, I'm not trying to find that problem 6 steps down the line. So let me go into interfaces. No, let me go to desktop. Interfaces. And apparently it's not capital I. Oh, it's still saved under the original goofy text file name. There we go. All right, compiles clean. We're good to go. Now we're going to make something that implements that. And I'm going to make a student class. And it's going to have a first name and a last name as an attribute. And a sequence number, let's say. We'll talk about the sequence number in a second. So it's going to have private string, first name, private string, last name, and then private int sequence number. What's your email address here at LC? Okay. Okay. So, okay. We're going to pretend it's first name, not last name, not initial. All right. So that way I don't have to mess around with that string function to pull out the first digit. So I'm going to have a lot of things in here, right? I'm going to have a constructor. It's going to expect, and we'll get rid of the sequence number. We'll ignore the fact that there's equal if there's more than one person with the same name. We'll pretend that doesn't happen. All right. If it does happen, we would just have we would have like a sequence number after it. And I'm going to take some shortcuts here in the interest of time. I'm going to simply set the first name to arg fname and the last name equal to arg lname. It is easier if you are used to doing that. The one thing that bugs me is like if you put your mouse over something, it like sometimes pops up a help hint, and it's like I want to type behind the help hint, you know. So yeah, you're absolutely right. Now, this implements the emailable. So I'm going to put implements emailable. I'm going to save this, hopefully in the right place. Let's see. We want on the desktop interfaces. We want to say this is a Java file, and we want to call it student.java. Now I'm going to compile. Even though this doesn't do anything yet, I'm going to compile. Because, and I'm telling you this so you know I'm not pretending and just covering up a mistake when it doesn't compile. This is not going to compile. All right. All right. Student is not abstract and does not override abstract method send email. What does that mean? Well, let's not worry about the abstract part because we're not making an abstract class, so that doesn't override the method send email. That means that because this implements that interface, there needs to be some method in here whose signature and name matches oh, I think I put it as an int. Yeah. Thank you. That one I would have been pretending and covering up than say I was just seeing if you're paying attention. Okay, I'm not going to send a regular email, but I'm going to output a line of a message out system print ln. Now, I'm going to put in here a string for their email address, and I'm going to construct the email address pretty much as you described, except I'm not going to get the first initial. That wouldn't be hard, but I don't feel like playing around with that. So their email address is equal to what? First name plus a dot plus last name plus at mail.Lorraine okay. And I'll save it. No, you can't. You could try. Thank you. This has been a crazy day, by the way. That's my excuse anyhow. Oh, okay. There we go. So this is going to be our pretend sending an email, and we're going to return a status code, which I'm going to say maybe a status code of 0 means it went. Okay. Return 0. All right. So now let me make my test class. I'm going to first start making a student. I'm very aware of time here. Student S equals new student. I have to give it a name, first name, and a last name. And again, in a real application, this would be coming from somewhere else. Maybe a database, maybe a GUI, something like that. I do have that constructor. Then I'm going to say s.send mail, send email. Or I can go like this. I'm not going to worry about the status code. We're going to assume all our emails send. So you know I send an integer. Okay, I go and save this. All right, so I save it. And let's compile it. Forgot something there. Works just great. All right, I run it. Forgot to say static. This is why I like to have examples prepared. Send an email to mike.zellers at that. Took and formed my email. All right. Now, I might go a little over today. I apologize for that. But I do want to get this in because remember, keep in mind, next week is spring break. So we don't have class next week. All right. I could make a totally different class. I'm going to make a class supplier. And it has a bunch of attributes, but the one that it has that I'm interested in is an email address. And I have a constructor that sets it. Get the right one eventually. Now, I'm going to say this also implements emailable. All right. Now, what would happen if we compiled at this point? We're going to get an error. Pardon me? Because there's no get email function. Exactly. No email. Oh. Okay. So we're going to put in a get email function or send email. Has to match the signature. If I made this public string and I tried to run it, it would give me an error because it has to take and return exactly what the interface specifies. Send email. Now, in this case, this function's easy, right? The email's already formed. So I'm going to say system.out.println. Notice that nothing about these classes are the same. They have totally different attributes. Each has their own way of figuring out the email to address to send. This one is just a plain old attribute. With student, you construct the email address based on their name. All right. Should be implements. Missing return. And it sends an email address. Oh, I forgot to attach the email address. What? Email sent to email address. In the unit. Oh, I'm telling you, I almost slept in for my first class this morning, and then the projector wasn't working in that room. So this is, oh no, really going to be out of sorts. And it sends the email. Now, last thing we're going to do, we're going to finish up here, is I can also do this. And we don't have the time, but if I did have the time, I'd put these two emailables in an array list of an emailable so I could loop through them all. But I can declare it as an emailable and I can put a student in there. Why? Because a student is an emailable. Remember, interfaces are a form of a is-a relationship. All right. It's just sort of a weaker is-a. In other words, a faculty member is an employee. Yeah, that's strong. You know, a faculty member is someone that you can email. Well, that's true, but you know, so I can do this and I should be in good shape. And this will be called polymorphically. So you don't get the benefit of sharing code when you create an interface, but you do have the benefit of being able to treat it polymorphically. And that is the huge benefit of interfaces. Any place any function that requires that you to send emails to any entity, as long as you implement that function, you're good to go. That was the name of the interface, right? You would say just an interface. And again, I know that's a little confusing because usually people think of user interfaces when they hear interface, but this is a different kind of interface. It's still just a .java. An interface is, strictly speaking, like a class, but it's called an interface. An interface is really a lot like an abstract class. Yeah, I would create, yeah, if you're going through that, I'm going to create a pointer called S that can hold any emailable thing. I create a student and put it there so that pointer will point to a student object. Exactly. And if I mess up and don't put it in there, if I spelled email wrong, or I got to include that, I get a compile error on it. That's what I mean by it's being a contract. It's a guarantee that I can, it's a promise to the compiler that I can call send email because this implements that interface. And you literally can't compile if it doesn't. Can an interface have instance variables? I think that is a new addition to the language. I don't think it was used to be that way, but I do think it is that way now. Interfaces could also have what's called a default method. So let me look. Interfaces, properties, Java. Properties, it can, but they have to be final. Let's see. Yeah, an interface. Yeah, right. Yeah, you probably could create, apparently you can create a interface. It looks like a final. It has to be final then. You can also describe default methods, like send email might have a default method of whatever. That's not a good example. It really wouldn't be a default thing, but you know, there could be a default rule for some interfaces. All right, questions? Yeah, let me Google that too, because these are new developments. Right. You declare them with the keyword default, and they provide an implementation. Default, well, they would be overwritten if you wanted to. All right. So this is turn alarm on, turn alarm off. If you have a car, you don't have to declare the turn alarm on or turn alarm off because that default was supplied. All right. But you could override it if a different object was there. Now here's a goofy thing. What happens when a class implements several interfaces that each define the same default method? I don't know. You get into the same problem that you had with multiple inheritance. So To solve this, we must explicitly provide an implementation. We would say which one we wanted to use that way. This is almost allowing us to do multiple inheritance in a way. Maybe this is like me being old-fashioned, but I generally prefer the old-fashioned interfaces that are just methods. It seems like there's a lot of complications that you get into when you specify default methods. I guess maybe not a lot, but some. And I guess there's a benefit to it, but it seems a small price to pay to define the method in each place. Hope the power's not going out. All right. Are there any questions? All right. Thank you. We'll see you in 2 weeks then. Yeah, you too.